Hi everyone. We can start after 2 to 3 minutes. Some people will join. Okay. We can start. Uh, we will join one by one. Okay. My name is basically Somakanto Maji. Currently, I am the second year PhD student from IIT Bombay. So we will taught here basically organic, and we will solve three questions from organic from GATE 2019. Okay. If you have any question anytime, just stop. After the solving the question, I will give related type of question you have to answer. Okay. So there are 2 to 3 people I think new here. Riyasat, are you here?
Yes, sir.
I think you are the first time attending my lecture, right?
Yes, sir. Yes, sir.
Okay. What background you are doing basically? MSc, BSc. Uh, what background? Are you student or you are doing any job?
Sir, I'm doing private job.
Okay. Good. Now you have to qualify GATE, right?
No, sir.
Okay. Somebody. Okay.
I was completed MSc chemistry. Now I am doing job.
Okay. Good.
Yeah.
And I think Robindo had joined last time also.
Yes, sir.
Okay, good. Savan, Purohit,
Yes, sir.
what background you are student or you are doing job?
Uh, right now, I am the student of MSc,
Okay.
third sem.
Okay.
Okay, thanks.
Okay. We will now play one video. So before solving that video, I will encourage to first solve yourself. I mean, first you choose one option and let's see your option is correct or not. So I will stop meanwhile. The voice is audible, I think.
Yes, sir.
Okay. Now
Hi everyone.
Okay. First read the question, then we will solve.
The screen was not shared.
Sorry.
Screen is not shared.
Now it is okay, right?
Yes.
Can anyone tell me what type of reaction it is?
Pericyclic reaction.
Yes. And what type of name reaction?
P3 sigmatropic.
Okay. And what type of sigmatropic? I mean, 1, 1, 2, 2, 3, 3, 4, 4,
P3
5, 5.
3 3.
Okay, good. Can you predict the stereochemistry? What will you get the product?
Um, just a minute. So A is the option, sir.
Sorry.
A, only one. Both
Okay.
are in the trans.
Okay. Okay. Let's see. Solve this question.
Today we will discuss about one gate question, gate 2019, question number 13. So the products formed in the following reaction is or are. So there is a one substrate and they basically heat it up and there is three options. Here one trans bond is there and two trans bond is there. Here one cis and two cis bond is there, right? So here two trans, two cis and here one trans and one cis bond is there. Okay, so the correct option we have to find. So for that we have to know the this is the one question from the pericyclic reaction and the name reaction is basically the Cope reaction. So in the Cope reaction we have to first numbering. So that is basically a 3-3 sigmatropic rearrangement. So when we see normally in the system like two double bond and for that we have to start the numbering like this: 1, 2, 3. Like here 1, 2, 3, and 1 prime, 2 prime, 3 prime. If this type of relationship is there, then there will be a possibility of one dash bond breaking and a new bond will form in between 3 and 3 dash. So the product will be like this. Okay. So the product is basically this. So basically no change in this case. This is a normal sigmatropic rearrangement observed, which is basically the Cope rearrangement. So come to the question. So in this system, there is basically two CH3 group. They are basically switched to each other. So and we have to configure whether our new bond that will form, that is whether cis orientation or trans orientation. For that, we all know that the chair conformation is most stable conformation in the cyclohexane because this type of reaction will proceed through a six-member transition state. So that's why we have there is many possibility like skew boat, chair, half chair, boat. So that but in this case we have to draw our structure in the chair form and that chair form should be most stable chair form, I mean most stabilized form. So for that we can redraw like this form like this. So for that let's do the numbering again. So this is 1, 2, 3 and this is 1 prime, 2 prime and 3 prime. So what will happen? 1 bond will break and there will be possible will form a 3-3 break, 3-3 prime bond. So for that we like do this and this will come and this will form a transition state like this. Okay. And one thing we have to notice that one CH3 group is in axial equatorial position and another group is in axial position. If we flip this ring, I mean this is actually one conformer. If we basically
Sir,
change the
voice is not
conformation,
clear.
then
Okay, okay. Okay, okay, I'll explain that. So first is basically that we are basically heated up this reaction. Okay. So we can draw this structure like this. You are getting this structure because both are in cis conformation, right? Are you getting this to this conversion? You will tell or not? Are you getting the conversion?
Yes, sir. Voice clear है आपकी.
Actually, when we are basically playing the video, na, that's why the voice is basically quality is low. So,
Yes, sir.
after that, there will be the 1, 2, 3. There is 1 dash, 2 dash, 3 dash. Okay. So this bond will break and new bond will form. So the stereochemistry basically decided by this 6-member transition state here. Using this 6-member transition state, the stereochemistry will be decided. Okay. And that the cis whether the our new bond will be cis cis or trans trans or cis trans that will be based upon this chair like transition state. Okay.
also we'll get one CH3 group in axial and another CH3 group in equatorial position. That's why this chair conformation is the most stable conformation. Okay. So the reaction will go like this and we'll get the product like this. From this transition state, this is the transition state and we will get the product like this where the one bond will be trans and one bond will be cis. So there will be this is a cis bond and we will get here one trans. So in our question, let's see there is any option or cis one trans. See here both are trans. Here both are cis. Here one trans, one cis. So the correct option will be C. So for more this type of information, you can watch this NPTEL video. Thank
Okay, I am giving one question, try to solve this. Suppose the same question, suppose the same question and one row is upside and another row is downside. So what will happen? Like this. So what will happen? First tell you people are getting or not the question and the I mean the solution because the voice is not clear now. If you get, then solve this question and try to tell what will be the answer. Anyone? I think it will help. Just one sees one turn. Just draw a transition state and tell me the answer.
both will be trans.
Sorry, can you repeat one time?
The double bond present at both ends will be at trans position. So here this is one cis and one trans. Then if we change
Okay,
the orientation of
okay, that will be both trans. You are trying to say, right?
yes sir.
Okay,
Both
okay, let's
cis,
solve.
sir. Both cis.
Is Kali right? Because see what happened here. So basically here, see here both group in the cis position. That's why one should be axial and another should be equatorial. But here both group in the trans to each other, right? So we can draw the chair like in this form, or we can draw it like this. Like where one group will be like this and like this. Both will be in axial position, right? That conformation is not stable because due to the 1,3 syndiaxial interaction. You all know that, right? So both groups should be in this case in equatorial position. So then if we break like this and like this and like this, so what we will get? We will get two trans. So the product will be the trans. I hope everyone will got this, right? Anyone have any question can tell if you're not getting. Okay, fine. Then the next question.
Hi everyone.
First read the question and tell me the answer. It may be correct, it may be wrong, no problem. So the number of 1H NMR signal observed for the following compound is
5.
5, right? Any other answer? Others should try, at least try. You all know the 1H, I hope. So everyone agree with 5?
18, sir.
18. Okay. Any other answer?
6, sir.
Okay. Okay. Let's solve now.
Today we discuss about one gate question from 2019, and that is question number 16. The question is basically the number of 1H NMR signal observed in the following compound is. So there is one compound, and how many different type of 1H NMR signal we can observe for this reaction. The meaning of this reaction is that how many chemically inequivalent photons is there. So let's come to the some general introduction. So the first thing is that there is the if there is plane of symmetry, center of rotation axis of symmetry or inversion center of symmetry, this type of symmetry is there, then the protons will be basically chemically equivalent. Okay, they are basically chemically equivalent. So let's take some example. Let's take the normal benzene. It has C6 axis, sigma plane, like these, and there is also a C6 axis. So that's why all the photon are equivalent. That's why we get only one peak in 1H NMR. With some lock system like cyclohexane. If if we freeze the cyclohexane at lower temperature, like say -100 degrees centigrade, we will observe that two different photons at one photon for due to the axial and another photon for due to the equatorial. We normally know the equatorial photon will be more decelerate than the axial due to the ring current. So we will observe that at the very much low temperature when the conformation is basically freeze, I mean this type of interconversion is not possible. That time we will show two peaks. But at the room temperature, this type of interconversion is very much rapid. That's why we'll get a average peak in between two. That's why so at room temperature at RT means room temperature we'll get only one peak, but at -100 degrees centigrade, let's say we will get two peaks because due to the
So you people getting this or not? The cyclohexane. So basically cyclohexane can exist in this two form like, so here the cyclohexane has no substituents, so it can adapt two type of conformers equally, right? So let's say at the room temperature, the conversion from one conformer to another conformer is rapid, right? That's why axial become equatorial. At the same time, equatorial become axial. That's why we get average spectrum. That's why we get the one peak. But when we do the lower temperature, I mean at lower temperature, we are not giving the sufficient energy to flip the two conformer. That time, the axial hydrogen should be in axial because there is no flipping. So that's why that time we'll get two different peaks, and among them the equatorial hydrogen will be always decelerate than the axial because due to the ring current. I hope it is clear. Okay. But if we substitute one group like tertiary butoxide in the next case, so we'll observe that ring flicking will not happen because due to the 1,3-diacetyl interaction. That time we also get at room temperature two different peaks for axial proton and the equatorial proton. And another thing is that if there is any chiral center in the molecule, the CH2 proton, I mean, we normally know the CH2 proton are same, but that time CH2 proton will be the diastereotropic. So each hydrogen will show different peak.
log of the conformation. But if we substitute one group like tertiary butoxide, so tertiary butoxide group cannot be stable in the axial position due to the one-stage axial interaction. That time we will observe that these two hydrogen will show two different peaks. Okay. So, and another thing is that if there is any chiral center in the molecule, both the CH2 group will be in diastereotropic in
Can you tell me where is the chiral center in this molecule? In the last example, where is the chiral center?
No chiral center, sir.
Sorry,
No chiral center.
there is chiral center in the last molecule.
In chlorine, fluorine containing carbon, sir.
Yes,
Uh, yes, sir.
yes, sir. So two different
Two
group is
are.
there. So that time it will be chiral, right? If the one chiral center is there, then this CH2, right? We know that CH2 give normally a single, right? Single, they are equivalent, but that time these two CH2 are not equivalent. They will show different peaks. Okay, just this thing remember. But CH2 will be equivalent because due to the bond rotation.
nature. So here is the one chiral center, right? So due to this chiral center, these two
Yes, still, Ravindra.
Sir, I would like to ask that all four hydrogens are diastereotropic.
Yes, here these four hydrogen CH2 CH2 all are diastereotropic. and they will show at different position. They will show 4 peak. Okay, I mean at different position. Normally, if we take CH3, CH2, 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 CH3, that time CH2, CH2 will be equivalent. But in this case, due to the chiral center, these two hydrogen will show two different peaks. Okay, are you getting?
Okay, sir. Yes, sir.
Yes. Okay, that remember, it is very important. Anyone?
Proton is chemically non-equivalent, and these two protons is also chemically non-equivalent. So due to these two protons are basically so different chemical shape in the one H. So now comes to the question. So this is our molecule. So now the question is there any chiral center? No chiral center. But there is the one pro-chiral center here. If we substitute anything here with this,
Okay. Can you say any molecule? I mean, any symmetry here? Can you find in this molecule? Can you able to find any symmetry like center of symmetry, rotation of symmetry, or inversion symmetry?
No, sir.
Okay. Anyone? Can you find any symmetry? Okay, fine.
center will be chiral. So there is a pro-chiral center. Okay. So and now the question is there any sigma
You will know the prochiral meaning of the prochiral.
Yeah, yes, sir.
Yeah, okay, okay, fine. Prochilous means just before chirality. If we
Huh.
change anything, that will make chiral. Suppose here in the 5-member ring, oxygen CH2, CH2, and oxygen. If we attach anything here, that center will be chiral.
CN axis of symmetry? No. I no. But there is a sigma plane center of symmetry like this. There is one sigma plane. Due
So it is difficult to visualize that there is a sigma plane, but there is a sigma plane because due to this, if we assume that these two group like a ball, because there is a rotation, right? So due to this rotation, if we assume that at one position there is a like ball, so we can pass a symmetry, right? So there is a sigma plane. I mean, if you visualize it 3 dimension, I think we will get, because this OCH3 is at not this side always. It can be opposite side also, right?
to this sigma plane, these two CH2 group becomes chemically equivalent, and this hydrogen is also become chemically equivalent. Okay. So the first peak will be observed for this one. This is two. This is three, and this is four. But you will think that due to this sigma plane, these two hydrogen are equivalent. But there is some trick. So
So one student tell me that there will be five peaks, but in the most of the people will write the five because due to the sigma plane. But this is the log system, right? When there is a cyclic system, so you have to think. So that thing you have to
we
important.
can draw this structure like this. This is a five-member ring. Five-member ring here. And we are also drawing a five-member ring. One CH3 group, let's say upside, and aromatic, the portion is like this. Yeah, we have presented by here. So the basically sigma plane is passing like this, right? In between the. So now think if so in this case these two CH3, this H and this H are chemically equivalent due to the sigma plane. Similarly, this H and this H is also equivalent due to the sigma plane, but these two H are not equivalent because this hydrogen is same side towards the CH3 and anti towards the air. Basically, if we take this hydrogen, let's talk about this hydrogen. This hydrogen is CH2 CH3 but anti to air. So they will so which hydrogen is upside and which hydrogen is downside. they are basically not in the same environment. So that's why these two are not equivalent. So
So, are you getting why this age and age are not equivalent? Although there is no chiral center, because one hydrogen, let's say if we think that these two hydrogen are in equivalent, then what happened? One hydrogen is seized to the CH3 and turns to air, but in the lower portion hydrogen it seized to air but turns to CH3. That's why their environment is different, right? That's why they are not equivalent. I mean, they are not equivalent. Are you getting? You tell me. Okay, fine.
that's why we'll get different peak. So how many peak will you get? So this is 4. So we'll get this is 5 and this is 6. So we will get 6 peaks in this spectrum. Okay. So how many 1A signal? We will get 6 signal. Okay. So for more information, you can watch this video. Thank you.
Okay. If you get this question, then tell me how many 1H will show in room temperature and minus 100 degrees centigrade at RT and minus 100 degrees centigrade for this molecule. This is DMF, N-dimethyl formamide. Anyone? How many different type of proton is there? First tell me.
So
Okay, two. Now tell me at RT how many peak we will observe and minus 100 degrees centigrade, how many peak we will observe? Okay,
R-
so
at RT 2 peaks मिलेंगे
RT,
minus 100 2 peaks.
RT 2 peaks and minus 100 degrees centigrade.
उसका कुछ पता नहीं चल रहा उसमें.
Okay, see what happened in RT. This is the DMF, right? So there is a conjugation, like nitrogen center will come here and like go like this. So the another structure can be like this. So at RT, this type of equilibrium will be fast. Okay, I mean these two equilibrium will be fast. That's why we'll get two peaks, because one CH2 will come like this, and at the same time, due to the bond rotation, this is CN bond rotation, this CH3 and CH3 will opposite, right? I mean bond rotation is possible at RT. That's why we'll get two peaks. But at minus 100 degrees centigrade, this equilibrium will be very slow, right? That's why this CH3 and this CH3 they are in different environment because this CH3 the oxygen is in this side, right? It is near to the O minus, so that proton will be shielded, right? But in this case, this CH3 is near to hydrogen, so their environment is different. That's why at the minus 100 degrees centigrade, they will show three peaks. Are you getting or not?
Yes, sir.
Fine.
Excuse me, sir.
Yes, yes.
Sir, here in this molecule, will inversion in nitrogen will play a role?
Inversion is nitrogen playing a role because in nitrogen center there is a two type of inversion, pyramidal inversion, and there is also CN bond rotation, right? I mean there is also rotation, na? Single bond always rotate, but double bond never rotate. You know, right? So when there is a single bond at RT, this equilibrium is very fast. That's why this CH2 will just rotate and this will come that side. So they are basically equivalent. But when at minus 100 degrees centigrade, this equilibrium become very much slow. That's why this form will predominate and will get only three peaks, but at RT two peaks.
Okay, sir.
Okay. Can you predict the chemical sheet of this hydrogen? Any rough guess of this aldehyde hydrogen? Okay. Just remember this aldehyde proton comes around 9 to 10. Delta value equal to 9 to 10 ppm. Okay, that is the signature peak. Always remember, aldehyde comes around 9 to 10. Okay, fine. Tell. Hello, Ravindra.
Sir, in the question you have discussed, you said that there is a sigma plane. The sigma plane is perpendicular to the plane of paper.
Okay,
Am I right, sir?
uh, in this question, right? Yes, this is the perpendicular to the plane of paper. See, this is passing through the. If we draw a molecule like this, then it's like passing through the CH3 and air. The CH3 and air,
Yes, sir.
like this, like CH3 air, perpendicular to the, like. I hope you got great. Okay, now the third question.
Hi everyone. Now we'll discuss about
First, read the question. Okay, can anyone tell me the answer? In one case, R is equal to hydrogen, another case it is ester.
D.
Sorry,
Fourth option. Fourth option.
option D. Okay. Any other?
B option.
Okay, let's solve it.
One gate question from 2019. That is question number 30. So in this question, in the following reaction, the major product P and Q are. So this is the substrate where OR is on one case hydroxy group and one case is the COAT, I mean keto group is there. So in both cases, what is happening basically that the epoxidation is happening, right? So we have to just decide which is the proper stereochemistry in epoxidation. Okay, they use per-benzoic acid PHCO3 and benzene 0 degree centigrade in both cases. The reaction condition is also same. So let's take some basic. So if the double bond is there and if we use this pH C double bond O, bond OH. So the speciality of this thing is that this oxygen is that due to these two both this oxygen has lone pair. So due to this lone pair repulsion, this oxygen becomes basically nucleophilic in nature. And another good thing is that good thing is that this pH C double bond O, bond O, H. This can act as a also electrophile also. Electrophile. This can act as a electrophile also because if we add something here, let's say one nucleophile, that will produce pH C double bond O minus. That is also resonating stabilized, right? I am not resonance stabilized. This carbon will be stabilized. That's why this particular this particular oxygen can behave as a electrophile as well as nucleophile. This is the special oxygen.
Mhm. So you're getting this oxygen is basically special. This oxygen can act as an electrophile as well as nucleophile. Normally, oxygen behave as a nucleophile, right? But here nucleophilicity is extremely high because due to the lone pair repulsion. Okay, and simultaneously this oxygen can behave as also electrophile also because the conjugate anion will over gate that will be stable, right? So that is the special thing about this oxygen.
For the paracid. So now let's come to the question. In one case we have OH and another case we have R is equal to COET, right? So what will happen? In the case of OH, there is a possibility of hydrogen bonding between this oxygen and this hydrogen. Due to that, the reaction will happen from the OH side. So the reaction mechanism is like this. This oxygen lone pair first donate here. So this is behaving as a nucleophile and again it will act as a electrophile. So it will take this double bond electron and what happens? This bond will come here, this will take and this will break. So we'll get our product from the same side of this OH group. But in the case of COET group, there is a no possibility of hydrogen bonding. So if this molecule comes from the upper side, they will face steric. Due to that, this molecule will come from the lower portion. Similarly, same mechanism. It will give this and it will take this and this come here. This will take this hydrogen and this bond will break. So, so in the case of OH, we'll see same side attack. But in the case of other group, as the steric is predominant, we will get opposite side attack. So the answer will be here. Here in this case OH, the epoxide will be in same side. So this is in OH, same side. So these two options are wrong. So among these two, in the case of this H star, the hypoxide is a defined phase. So the correct answer will be B, right? Not this one. So correct answer will be B. So more this type of video, you can watch this NPTEL video. Thank you.
So any question? Okay, hello. Is there any question? Then I will give some question. Okay, fine. Can you tell me how many peak will see in 1 H for this molecule? Any answer? Just basically molecule is this. If you draw this hydrogen, how many peak will see in 1 H? Please tell the answer. I mean, it may be wrong. No problem. I will explain.
Sir, 3 peaks
Okay.
for the first one.
both question are same. I basically this hydrogen basically make difficult complicated. That's why I'm making like this. Both are same question, right? Only two CH3 in same site. They're in same site. Okay. Just tell me 5-membered ring, two CH3 same site, one carbon after. How many peak will observe in one each? So okay, tell me there what symmetry present in this molecule? What type of symmetry? I mean center of symmetry, rotation symmetry, inversion symmetry, plane of symmetry.
So plane of symmetry is there.
Okay, in which carbon to which carbon? I have. Can you tell me? I mean, from which position there is plane of symmetry is basically coming?
C1 carbon 2 are that breaking the bond in sir.
Okay, C1 to in between C3 and C4, right?
Yes, sir.
So that's okay. So due to that, what happened? So if we make the all the hydrogen, if we write all the hydrogen like this, like this, like this, like this, and here also two hydrogen is there, right? So it is complicated to see. So due to this sigma plane, this hydrogen and this hydrogen are equivalent, right? Similarly, this hydrogen and this hydrogen are equivalent, right? Similarly, this hydrogen and this hydrogen are equivalent. Okay. Now tell me in upper side how many hydrogen is there? In the upper of the I mean Cl side, three hydrogen is there. Tell me yes or no. In the Cl side, I mean upper of this ring, how many hydrogen is there? Total three hydrogen is there.
Yes, sir.
Yes, no. And among them, two are equivalent, right? So how many peak will see? Due to this two one and this hydrogen one, so we'll get two peaks, right? Due to the upside. Now come to the downside. How many hydrogen is there?
5 hydrogen.
Five hydrogen is there. And how much hydrogen are equivalent to each other? How many are equivalent to each other?
Two
So
hydrogen.
this is one pair and this is two pair. So two pair are equivalent, right? Is it okay or not? Two pair are equivalent, right? So it will show only three peaks. Is it okay or not? Tell me. There is five hydrogen. Among them, these two and these two are equivalent. So how many get? This is one, this is two, this is three, total three. Okay. So total how many peak will get? Two plus three, five peaks. Right. And this, if we draw like same question, and these two hydrogen are not equivalent because one hydrogen is shifts to both Cl and another hydrogen is turns to both Cl. That's why they are not equivalent, right? That's why we are thinking that upper side there is a one type of magnetic field and the lower side that's there is another type of magnetic field. I mean their environment is different, right? That's why we are thinking the question like upside and downside. Okay, let's do one more question. Same question. So one upside and one downside. Now tell me how many peak will observe in one edge and one. Any answer? First tell me any symmetry is present in this molecule. Any symmetry present in this molecule? Sigma plane? Yes or no? Tell me at least. Okay. Ravinder is telling 4 peaks. Okay, tell me.
Sir,
Is there any sigma plane?
no, sir.
Axis of rotation axis? Rotation axis of symmetry CN. Okay, there is one rotation axis of symmetry passing through this C2 axis. I mean, if we rotate it 180 degree, this CL will go upside and this CL come downside. Is it okay or not? Tell me. There is a rotation plane of symmetry passing through this 1, 2, 3 and 4. And this CL, if you rotate this CL come this side and this CL go out upper side. So that is basically their equivalent. So due to this hydrogen and this hydrogen become equivalent. That time sigma plane same side is equivalent, but due to this rotation, the diagonal relationship will be equivalent because the plane should be passing like this, right? So rotation means 180-degree rotation, right? So that's why this hydrogen and this hydrogen will be equivalent. Similarly, this hydrogen and this hydrogen will be equivalent. Okay, so that's why we'll get how many peaks? Here this one for this diagonal one for this one. So two peaks due to this four hydrogen. Now come this side. This hydrogen and this hydrogen also equivalent. That's why you will get another one. Similarly, due to rotation, this hydrogen and this hydrogen also equivalent. So another one. So you will get total 4 peaks. Tell me, is there anything wrong? I mean, I was not getting on. So I am explaining one more time. So see, first see this, there is a plane of symmetry passing through like this, that is C2 axis. So that's why this Cl and Cl becomes equivalent. So if we pass again the same operation here, so this hydrogen, this hydrogen and this hydrogen become equivalent because they are after 180-degree rotation they will come same side, right? If we rotate it 180 degree, this come here and this come here, right? So that's why they are equivalent. Similarly, these two are also equivalent. That's why 2. Now carbon to the next carbon. Same in this 2 and 5 carbon, there is this have one hydrogen and this also have one hydrogen. So they are also equivalent due to this symmetry. That's why one more. And in the one, if this edge and this edge also they are equivalent due to the rotation. That's why again one. So that's why you are getting total 4 signal. Okay. Is there any question? Tell me. Otherwise, we'll stop here. Any question? Okay, fine. Then we can stop. So thank you for joining.
Thank you, sir.